Okay, we're going to look at three Bay Area sports stadiums. We're going to look at San Francisco, Oakland, and San Jose, Levi. And I'm going to oversimplify because stadium dynamics have changed so much over the years. Stadium dynamics meaning atmospheric dynamics or stadium atmospherics. The idea that the wind flow, the prevailing wind, or any storm wind, whatever it is, rain, how that impacts the flight of a ball. And what happened back then, I guess it was SBC or AT&T, San Francisco's ballpark. That was one of the first asymmetric, newer ballparks, right? Asymmetric meaning like candlestick, symmetric, round, right? And most of the stadiums were Coliseum-esque. These stadiums now have these cutouts, and these cutouts right in here, and there's a scoreboard cutouts as well, have an impact on the play of the ball and the winds and how they flow. And so one of the things that we have found through our studies of atmospherics, we've done every Major League Baseball stadium in the country, quite frankly, outdoor stadiums, is that the lip of the stadium right up here and back here behind us, there's a lip, and there's a lip over here in right field. When the wind hits that, it refracts, it bends down and in. And so that's called the barrier effect. So prevailing wind at San Francisco, wind comes out off the city. It's a little turbulent because it's going through the city. If you ever look at that ballpark, it sits below, right, the city, but the wind hits it and then it starts to bend down. The barrier effect. It's like a wave. Have you ever seen a wave come around a point like a steamer's lane and it wraps and refracts? Well, the air does the same thing. It hits a solid object. The upper wind keeps going, but then it bends in. And in this case, on a westerly wind, the wind bends in and sinks. So you have seen the flags out in right field and like, what's going on there? That's the sink. So there's other impacts at this ballpark that I'm not going to get into, but I just wanted to point out it has a huge impact. Like it can affect the travel of a ball 20, 30, 50, 60 feet, depending on the wind speeds and the wind direction. So that is San Francisco. This is Oakland. The general wind direction is more westerly, west-northwest, or a lot of west in there. And same kind of a thing, right? You've got this area here where it hits the lip and the wind hits it and starts to refract in. And then you've got right field where the air begins to sink because of that, the wave coming around the point. So here comes the wind, hits the wall, and it starts to bend down. So what does that do? It makes right field at Oakland on a prevailing wind day, on the west-northwest wind day, which is almost always during the baseball season until you get into the fall, you're getting sink and you're losing carry in that field by as much as 50 to 100 feet again. Depends where the ball's hit, depends how high the ball's hit. We quantify all that, but the idea that just so you know, if I'm pitching outside pitches so that the ball goes out to right field because it's not going to have an opportunity. It's going to be much more difficult to get it over the wall. If I'm offensively hitting, I'm hitting towards left field and hitting away from right field for the similar idea. I want to get some carry on my ball. So here is Levi. I was here the other day. I mentioned it. I was watching him punt. There's a gap here. See the gap? That gap creates something called the Venturi effect. So you get a barrier effect from the top of the stadium, right? So the wind's blowing northwest over the scoreboard and over that stand. But then this gap in here creates an accelerated wind, a Venturi. When you compress wind, it's like fluid dynamics. When you compress something, the core of the fluid speeds up. That's like the Venturi. It's, again, oversimplifying, but that's what I do. So you get a little Venturi here, you get a barrier effect here, and it does the same thing. So watching the balls get kicked the other day, I was watching the punters punt, and the first thing I noticed was, holy smokes, the balls would go up, they'd get up there, they'd get a little push from the Venturi, but the Venturi was still bending down and in, right? So it's accelerating the curvature towards the playing field. So what did we just look at? We looked at three stadiums, and we looked at the idea that the barrier of the stadium wall impacts everybody in all stadiums. The cutouts, which are more typical now, can accelerate those differences in wind flow. So when you're at a ballpark or you're betting on a game or you're playing in a game or you're watching a game, just pay attention to where the wind is. And now you know why right field has in San Francisco has this sink to it, because that is visual. The other thing you can do too is at the end of most games when you watch the fireworks show, not most games, but in the summer they have fireworks often. Watch the turbulence. Watch the smoke and how after the fireworks are done. And you're seeing these circulations of air within the stadium. There's lots of little microclimates within the stadium. The stairs can affect the wind flow. The scoreboard affects the wind flow. But the most basic impact is the barrier and coupled with the asymmetric cutout Venturi effect. And that the Venturi actually accelerates the barrier. So I don't know. I mean, I think it's interesting as heck. It's one of the things. I have a company called Weather Applied Metrics, and we do this. And I'm not giving you all the secret sauce because that's what we do. But just know that the atmospherics, especially in Bay Area stadiums, has a huge impact on baseball and football.